Now for this last part of the question, we're told that as this particle's moving up at 16 meters per second, this force of 36 newtons is removed. And we've got to find out how far the particle then carries on up the plane. Now let's just remove that force of 36 newtons. So this would mean that these are the only forces left acting on the particle. And we've got to be very careful here because R will have changed now because of the 36 newtons being removed. So this frictional force here will also change dependent on what the value of R is. So how are we going to work out how far up the plane this goes before it comes to rest? Well, let's just add to this diagram that at this position here it's moving at 16 meters per second, but it's going to come to rest at the top here. Okay, 0 meters per second we'll say. So this sounds like it's going to be a problem based around a Suvat equation, an equation for constant acceleration. So if we think ahead and we think of our Suvat equation, S for displacement, U for initial velocity, V for final velocity, A for acceleration and T for time. We're trying to find out what that displacement S is from here to here, and we'll take up the plane as positive. So do we know U? Yes we do. It is 16 meters per second. Do we know V, the final velocity? Yes, it comes to instantaneous rest, 0. And then A, the acceleration. We don't know that. We don't know the time either. So we need one of these variables here in order to work out what S is. Well, it's going to have to be the acceleration. Because we can get that acceleration, let's just mark it in here, by considering resolving up the plane in the direction of motion. And we can expect that acceleration to be negative. It's a deceleration, it's slowing down. Now in order to resolve up the plane, I can see that we're going to involve R. So in order to get R, because it's changed, we're going to need to resolve perpendicular to the plane. So that's essentially what we're going to have to do. We're going to resolve perpendicular to the plane to get R. Once we've found out what R is, we're going to resolve up the plane, apply Newton's second law of motion, F equals ma, to get A, and then put that value of A into the Suvat based equation, the appropriate one, to find out what the displacement S is. Okay? So that's just an overview. You might like to pause the video at this stage and have a go and come back when ready and check your solution with mine. Okay, welcome back if you had a go. So let's start off then by resolving perpendicular to the plane to try and find out what that value of R is. So we'll resolve perpendicular to the plane, okay, away from the plane being positive. So we're going to have all of R acting away from the plane, so it's going to be R. And then we've just got the component of the weight acting into the plane, and that's going to be minus 4g cos 30 degrees. Okay, 4g cos 30 degrees. Obviously we can forget about the mu r because it's perpendicular to the direction that we're resolving. So this equals 0 because it is in relative equilibrium to the plane in this direction. So therefore, if we rearrange this, we can see that it follows that R equals 4g cosine of 30 cos 30 degrees. You can work this out if you like. It comes out at 33.9481 and so on, okay, newtons. Now we can resolve up the plane. So if we resolve up the plane, always resolve in the direction of motion, okay? So up the plane is positive. What we've got now is a negative force here, minus mu r, okay? All of that acts in the opposite direction. And then we've got to take into account the components of the weight down the plane. Remember, it excludes this angle of 30 degrees in this angle of 90 here, so it's going to be minus 4g sine 30 degrees. So minus 4g sine 30 degrees. Obviously we don't have to consider the r because it's perpendicular to the direction that we're resolving in. So this is our resultant force, and that equals the mass times the acceleration. The mass, remember, was 4 kilograms, so that's going to be 4 times a. Now, to get that acceleration then, all I need to do is divide both sides of this equation by 4. Now, I'm also going to substitute the values that we've found earlier. Remember, we found out that mu, the coefficient of friction, that won't change even if we've removed our force here. It's a constant value, and we found out that it was 0.72590 and so on. So I can put that into there, and we've got r from up here. So what I'm going to do then is just put these values in. So we've got minus mu, so that's going to be 0.72590 and so on, multiplied by r. I'm going to leave r as 4g cosine 30. There we go, 4g cosine 30, 4g cos 30 degrees. And then we've got minus 4g sine 30, minus 4g sine 30 degrees. And all of this is divided then by the 4 that we've got here. Now you've got some calculation to do on your calculator, so if you do that, you should find that a turns out to be minus 11.0608 and so on. We would expect a negative value, okay, because it's decelerating. Now that we've got a, we can turn to our Suvat based equation. Let's just put that a in now. It's minus 11.0608 and so on. So what equation would we use for something like this? Well, it's going to be v squared equals u squared plus 2as. So let's just put that down using v squared equals u squared plus 2as. Then we've got v, which was 0, so squared, still going to have 0, so therefore we have 0 equals u squared, 16 squared, plus 2, multiplied by that acceleration, which is minus 11.0608, and so on, multiplied by s. So 16 squared is 256. This is a negative term, we can add it to both sides, so then we get 2 times 11.0608 and so on. S equals 16 squared, which is 256. And to get S, we therefore have S equals 256 divided by twice 11.0608 and so on. And what you end up with is 11.572 and so on. Okay? Now let's just round that, say, to 3 significant figures, and therefore we have S equals 11.6 meters to 3 significant figures, 3SF. Okay? So quite an involved problem, but hope if you had a go anyway that you were able to get it right, and if not, that you've been able to follow my method. All right?